Hello, everyone. Welcome to the LIUniverse. I'm Dr. Charles Liu, and whether you are artificially intelligent or naturally intelligent, please do call me Chuck.
Oh boy.
It is, it is a pleasure, as always, to welcome our co-host, Allen Liu. Hey, Allen.
Hello.
Hey, have you been reviewing any artificial intelligence safety protocols lately?
Listen, it's something that you got to do. OpenAI and Anthropic and those guys keep putting out new papers all the time. You got to.
Really?
I have been reading some other posts about how they plan to keep AI safe, and I trust some of them more than others. Let's put it that way.
Okay, well, we need you to be on the ball for that when you're going to keep us all in a reasonable way. So thank you very much, Alan. I appreciate that. And today, what a wonderful, awesome, fun episode this is going to be, because we have straight from Oregon, Dr. Yvette Cendes. Hi,
Hello.
Yvette.
Hi.
Hey, you are well known in social media and in the world as a person who talks about astronomy all the time, which I think is pretty awesome. But this is the first time that we've ever chatted in such an environment, which just blows my mind, because the sense that like we have been passing like ships in the astrophysical night for years, and this is the first time we've had a conversation. I'm amazed. But thank you so much for being with us, and tell us very generally right now what kind of stuff to do.
Sure. So I'm a radio astronomer. And, I'm a first-year professor right now at the University of Oregon.
Yes.
And my research group, we're interested in transient radio signals, so things that turn on and off instead of being constant in the sky.
Ooh, nice.
The reason we care about that is most things in our universe, like your galaxy or your star, do not really change that much in our lifetimes as humans. But if you have something like a giant space explosion where a star explodes in a supernova, or a black hole shreds a star, or even a natural emission from exoplanet, can give off these transient signals. And those are the sorts of things I'm interested in.
So do these, I'm just curious, do these last like on the order of days or on the order of months or like minutes? Like what is it?
It depends on the signal. I mean,
Okay.
some of them are very short. Astronomers who look for pulsars, for example,
Makes
pulsar, you get a little millisecond blip every couple of seconds type thing, or fast radio bursts are just millisecond long duration. But you have things that can last many years, in fact.
That's cool.
what I
And they're
look at.
all transient because they all go away at some point.
Exactly.
Wow. Pretty awesome. We will get right into that in a moment. But first, of course, as always, today's joyfully awesome, cosmic, cool thing is directly relevant, actually, to Yvette's science about transients and changes and things like that. So I think that'll
joyfully
be really
cool cosmic thing.
right.
That's what we settled on.
Joyfully cool cosmic thing of the day. Yes, yes. Okay, thank you very much. It has to do with transients, but not on timescales of minutes or hours, but billions of years in the universe. Because just recently, the Dark Energy Survey, which is a scientific project that is gathering millions and millions of galaxy spectra and learning about the universe on an unprecedented large scale, has seemed to show that the dark energy that permeates the universe, that is driving the expansion and acceleration of the cosmos and its volume, might be variable. It might actually be changing. It looks like things might actually be weakening, when in fact at one point it might have been strengthening. And this is just amazing because, Yvette, you have to explain this to us a little bit. The overall expansion rate of the universe is accelerating because of this thing we call dark energy. But dark energy originally was better known as the cosmological constant, right? Which Albert Einstein described almost a century ago. And so we're saying that the constant is not constant? What the heck?
Yeah, so, I mean, I read the same papers you read. I'm not in this research myself.
I bet
But
you understand it better than I do. So please
Okay,
tell us all about it.
yeah, so the general idea is, 70% of the universe is made up of something that we don't understand called dark energy. like, 10% is normal stuff. The rest of the 20% is dark matter, which is a different thing, not the same thing. That's the first important thing to emphasize here.
Okay.
And dark energy, I guess in the 1990s was when it really took off, because people noticed that galaxies that are further away, or the universe is expanding, and galaxies further away from us are expanding faster in the amount that they're traveling away from us. And that means that there's not really enough material in our universe to kind of drive this going forward. I mean, there's a lot more complicated stuff I could say about that, but that's a good podcast level explanation. And as a result, though, I mean, that's such a huge problem that, like, how do you wrap your mind around this? How do you measure this? How do you do? It's very easy comparatively to measure, like, things are getting faster. It's very difficult, though, to measure, okay, at this age of the universe, it's going this fast compared to this age of the universe.
Makes sense.
So this is the change in acceleration, right? This is the, I guess, math people, this is the jerk of the universe.
I guess that's true. And yeah, I mean, the way to put this is, like, the universe is still accelerating in its expansion. And as far as we can tell, it's going to keep doing that till the end of the universe. Ooh. But it's more that rate has been changing. So it's not that, oh, now we're going to have a big crunch someday, like all of physics has changed. No, that's like something, unfortunately, we don't really see for people who like poetic beginnings and endings. That the universe doesn't really care about those.
I think it's perfectly okay that we are literally being jerked around by the universe right now.
Oh, yeah, totally.
Yeah,
But what else is new?
Fair.
Yeah. But I mean, the other thing to mention, I mean, this result, so it's also, as I said, it's really, really hard to make this measurement. It's millions and millions of galaxies and spectra, and they made up a giant 3D map of the galaxy. They're not yet at the statistical level where we're like, this is 100% what is happening. I think it depends what model you use. If we're talking science or speaking at it's 2.8 to 4.2 sigma, I think, confidence, and 5 sigmas gold standard in physics.
So we just need a little more data to be sure that this is the real
one. Like 3 sigma signals disappear all the time, right?
Yeah, because 3 sigma is like a few parts per thousand chance that it's
exactly
just by chance,
just random.
Mm-hmm. Yeah, so, and if you have millions of galaxies or that you're looking at, then you got to be extra sure beyond
they
that.
Basically need more data, and they need to analyze it more, and they're combining it with like supernova data, with cosmic microwave background data, all these different other models as well to gain that confidence that they need.
Makes sense.
Okay.
But it takes time to do that. And we'll see where this ends up, but it's very exciting.
Yeah.
Finally, the other thing I do want to mention is a lot of people are like, oh, I always thought that maybe it's like, okay, it's one thing like, oh, you thought it, but it's another thing to have actual evidence that's quantifiable to show this. And that's why it's such a remarkable achievement.
Wow. Right. That's really great. Yeah. The millions of galaxy spectra as well, not just this one amazing result is cool for all kinds of science, right?
Yes, I think you might be intrigued. Yeah.
Just a tiny bit. Yeah. I can't wait to start looking at that stuff.
Yeah.
And, there's probably transient information in there too for you to play with. Not to mention the gold standard of transient experiments that's about to come online in the next couple of months, right? The Rubin Observatory's legacy survey.
Yeah, we've been chatting about it because we've been excited about it for a long time.
Yeah, we talked about
everyone's excited about it. We're gonna have to do all sorts of interesting new things. Oh darn!
So. But you're oh darn! But you're a radio astronomer, right? LSST in the Vera Rubin Observatory is an optical and near infrared survey. So how do you, in your science, match up with that kind of stuff, which is coming down at, when it's going to be running, like coming down at a trillion pixels per night? I mean, it's amazing.
Oh, yeah, sure. So that's a great question. So the first thing to mention is, I'm a radio astronomer, but I have collaborators and colleagues who work at other wavelengths. So it kind of, I'm the radio person. So, the optical people find things. They're like, oh, looks like it's a TDE, tidal disruption event, or a supernova, or whatever we want to follow up on in radio. And then we will swing our radio telescopes and take a look. So the nice thing about transients is if you do optical X-ray, gamma rays, where these things first show up at the higher end of the electromagnetic spectrum, you got a little time till that signal migrates down.
Because as it's cooling down, it goes down the wavelengths.
Yes. So we get a couple weeks before chaos begins.
So you don't have to stay up at night waiting for like an alert to come in and say, "Got to look at it now."
I mean, I also don't, because we can do radio astronomy during the day. Yeah.
Boy,
Makes
that
sense.
sounds
Yeah,
that sounds
got
super
all the
smart.
it's got all the perks.
Yeah, I remember there was something about one of the AAS American Astronomical Society meetings had something really early scheduled, like early in the morning. I was like, that must have been the radio astronomers who scheduled that. The optical people would still be asleep.
Oh yeah. Get up at 8 a.m. on a Monday to hear a science talk. Are you kidding me? I became an optical astronomer for a reason. Okay, so you mentioned something really fast in passing just now. You said TDEs, a tidal disruption event. Tell us about that, because I think you're a world expert on that, aren't you?
I guess so. Yeah. So a TDE is a tidal disruption event, or TDE for short, which I'm not a huge fan of the name, but I'm not allowed to change it by this point, I think.
Alas.
Because a TDE is actually the process where you have a star that wanders too close to a supermassive black hole and gets shredded by the tidal forces surrounding that black hole.
That's pretty awesome.
A much cooler phenomenon, in my opinion, than TDE tells you on its own.
If you had a chance to rename this TDE phenomenon, what would you call it?
Shredders.
Nice.
A shredder. I like it.
It would be like a heavy metal tie-in. Like we have a lot of
like the
That's right.
surfers.
Yeah.
Or Teenage Mutant Ninja Turtles.
Yeah. See, we have all sorts of options here, but somehow we got stuck with TDs. Actually, because of Martin Rees.
Start using shredders, okay?
We can do what we want.
We'll do it too, and then we'll get to it. Eventually, the IAU, International Astronomical Union, will have to decide.
Yes.
Tidal disruption event or
it could be the thing where like you have QSOs and quasars, right? Where like there's
that's true.
The abbreviation version of the name and then the fun version of the name.
I'm sure somebody will think up an acronym that is accurate for shredders. Yes.
Yeah. There you go. Right. And considering that some of the TDEs have like the name assassin in front of them for the completely different reason. Which you can talk about if you feel like it later on.
Assassin is basically a giant sky survey that found a lot of transients.
Yeah, that's awesome.
Yeah. Right.
Like B. Rubin. Yeah.
Nice. Amazing. Well, it's too much fun stuff to talk about. I can't wait to ask you about TDEs, shredders. As of this moment, in this episode, they're called shredders.
I don't know if we have that authority, but we can try.
We do for the next 40 minutes or however long.
That's right. True. That's right. So let's do it. Okay, but we should get to a question from the audience, right? This is a good time to do that. Alan, who do we got? What do we got?
Right. I think I'm going to ask the question that's most directly relevant to these shredder things. I think that makes sense.
Sure.
Cool. And this is from Nechama. I think that's how you pronounce this person's name. And Nechama,
maybe could be Nechama.
Yeah. Okay.
Nechama, whoever you are, thank you for asking the question.
Yeah, great. So this person's question is, when will the black hole in the Milky Way eat the sun?
Oh,
I don't know if that's a when, but
we are the shreddy in this case, right?
Well, I mean, the good news is the answer is basically it's never going to happen.
All right. I'm not going to change my retirement plans then. Okay.
Yes, exactly. So the first thing to emphasize is that black holes, despite common misconception, don't actually suck.
But if you fall in one,
well, yes. So like if your orbit is like going straight into one, you're gonna have a bad day. But it's not like you're a vacuum cleaner where everything around it gets sucked in and that just strays a little too close. So like the way to think of it, say our sun, if it were to become a black hole, this moment, it would instantly collapse to, I think it's like 2 or 3 kilometers wide or 1 kilometer, like
that's
very
small.
tiny size. But our orbit around the sun would keep going as it currently does. And, we would just, die of cold. Because we would suddenly start swinging toward the black hole and our orbit would change. So as long as the mass is the same, it's just that the mass is very concentrated in a very
because gravity only cares about how much mass there is, right? Like it doesn't care if it's like at a single point or if it's a sphere very much. So
I mean,
as long as you're far enough away from it, right?
I think there's a theorem about this in the physics class that I remember, which is that if you have a perfect sphere that's uniform density, then it acts exactly as a single point. But yeah, so it just pulls on gravity like everything else does, but it doesn't have special sucking powers compared to the rest of the universe.
Exactly. And I mean, it's a lot of mass concentrated in a very tiny area. So the area immediately around the black hole has a lot of weird properties that you don't have around, say, our sun. But that itself. Also, I mean, we're 30 30,000, 20,000 light years from the Sagittarius star.
Yeah, at least.
Yeah. So
something like that. So like, you know, as I said, there are stars that can wander too close and get shredded, but I think the odds of our sun suddenly, you know, zooming in on
we're out in the boondocks. We don't have to worry about it.
We don't really have to worry about those galactic dynamics. So yeah, good news.
Good news. The sun is going to turn red giant and die before it gets swallowed.
I mean, I do want to emphasize this because I've said this a couple times on social media, and then people will message me and be like, thank God you cured me of a childhood phobia that I've had for years.
Well,
and I'm like, wow, okay. We really need to be more clear on this black holes don't actually suck thing.
Keep spreading the word, Yvette. We need that to happen. Okay, we're going to take a short break right now, and we'll come right back with more questions and more fun stuff. We are at the LIUniverse, and we're talking with Dr. Yvette Cendes. Stay tuned. And we're back here on the LIUniverse with Dr. Yvette Cendes. I'm really glad that you are an expert on transient phenomena because there is something called the wow signal from the olden days of astronomy and space exploration. And I have not done my homework on this wow signal, but it has been studied for a long time, and it's called wow, not because of anything astrophysical, but because somebody wrote the word wow on a piece of paper. So Yvette, can you explain to us what that wow signal is and how we should take it as a transient signal in terms of what it might tell us about the universe?
Sure. So the wow signal was in 1977, I want to say, late 70s.
Wow.
There was a SETI experiment going on at the time, the Big Ear Observatory in Ohio, which is no longer there. But they basically had it was called a drift telescope. So you basically have your telescope that doesn't move. It just, everything that goes above you, you just see. And basically when it was going overhead, the next morning, you know, it had a data printout like on paper because this is the 70s. And the astronomer who went in saw a very loud signal. That was in the way the feed horn was set up. It was there for 15 minutes. Then they went through a second feed signal 15 minutes later, did not see it at that second time. And the trick is the signal was narrow band as far as we can tell. So it was not a gigahertz wide signal like a lot of astronomical objects are, that it was exactly at the 21 centimeter line, which if that's where the hydrogen is that you can detect in the universe. Right. So the guy wrote wow in the margin of this printout because that's just such a crazy thing that's like exactly what they thought a SETI signal would look like.
Extraterrestrial intelligence.
Yes. So if the aliens set us signals and you're like, I want people who are other astronomers, alien astronomers elsewhere, what kind of signal should I send them? This is like the sort of thing you should send them. The problem is they never saw it again. And people have looked at this patch of sky a lot of times over the years and have never seen this thing. So it is like very intriguing what could be going on. It should be emphasized at this point that the most likely thing it was some sort of weird man-made interference, because I assure you right now that is by far the most common thing that any radio telescope detects.
That's fair. So it was our fault, probably.
And it could have been like a satellite in a polar orbit, like all these things.
Yeah.
Once you hear that, for me, I've seen enough of this stuff that I'm like, okay, until we see another wow signal, it's really tough to confirm what this was.
That makes sense.
With that, I will say a caveat. I have a student, Kevin Ortiz Ceballos, who is a student now at Harvard and doing a PhD, and his advisor in Puerto Rico, Abel. I don't want to quote his last name because I don't remember Abel's last name. I'm sorry.
No worries. Just say his advisor.
You guys can look this up.
Yep.
He basically has gotten very into Arecibo, which was the biggest radio telescope.
Right, before it was sadly destroyed.
Before it collapsed.
Yeah.
RIP. Basically saw wow-like signals, he thinks, in the data. And so he's been working on that, and he's been working on digitizing the original tape data that is still, somewhere from that original Big Ear signal and stuff like that. So there is new people are re-examining this data now, and it's kind of interesting to see what's going on. I know some interesting things I cannot tell you because they're still working on it.
Okay.
Oh, no. Well, it sounds so conspiratorial.
Turn off the recording, I'll tell you.
Well, maybe at the end.
Yes.
Maybe at the end. So this student of yours is now at Harvard.
Yes.
You were also at Harvard for a period of time, right? Before you came over. And in fact, you've been like in many, many, many different places, haven't you? For a person who is in such an early stage of your career, you have been many, many places. Mm-hmm. And is that a good thing? I mean, moving around?
If all the moves are voluntary, then yeah, it's fantastic.
There.
Let's put it that way. The story is I grew up in Pittsburgh, Pennsylvania. I went to school in Cleveland, Ohio.
Oh.
I went and decided to do study abroad because I have an older sister. So she was 2 years older. She went to Australia. So I was like, okay, I'm going to do study abroad. I'm going to go to New Zealand. I'll admit this now that it's all these years later. I'm not sure I would have gone study abroad if my sister hadn't done it. So thanks, Linda.
Hey.
And I just loved it so much that I was like, I ended up doing backpacking between my bachelor's and master's degrees, for example. When I went back to Cleveland for my master's, and I was like, I really want to actually live abroad because then it's like traveling all the time. It's not, obviously, but it's more interesting than Cleveland, Ohio. I applied because I had a master's degree in physics, so I could apply for PhDs in Europe. Those require you to have a PhD. So I applied to various programs and decided to go to the Netherlands. And I lived in the Netherlands for 5 years.
Cool. A radio astronomy center for a long, long time. Right?
And the Dutch actually are fantastic astronomers in general. They have the most astronomers per capita of anywhere in the planet.
I mean, wasn't it a Dutch guy who invented the telescope like before Galileo used it to actually figure things out? Yeah.
Maybe.
Mm-hmm. Well, it was,
Yeah. Fantastic. Okay, so Holland or Netherlands, PhD, and then you weren't done traveling. You kept going. That's amazing.
So then I was I was hired to work in the Netherlands on a project that didn't work, and we'll leave it there. But I still had to finish, so I ended up going to Toronto, to the University of Toronto, Canada. Where I worked with Brian Gaensler, and that's where I
Supernova 1987A Supermeister.
Yes,
Brian Gaensler,
among other things.
Nice.
And then I went to Cambridge, Massachusetts, because this position at Harvard came up working for Ido Berger, who's a very good guy at transients. If you know anything about transient signals, Ido's done a lot of cool things.
Wow.
And then
now Oregon.
And now the University of Oregon,
which is wonderful. Wow, what a travel log! I think that's fantastic.
Yeah,
and
I have a question that's relevant to that. If we want to ask it at this point.
Oh, you mean like from an audience member?
Yep.
Sure. Okay, let's go for it. Make it happen.
All right, cool. This question comes from Yanmin, who is asking, relevant to this conversation, where is the best place in the world to study astronomy? I live in New York, or Yanmin lives in New York. Is it New York?
Oh, well, that's cute at the end there. Would New York be a good place to do astronomy?
It's not a bad place to do astronomy. If I had to choose one place to send someone who's like, I want to be the best astronomer there is, like, this is a severe bias on my part, but I would send them to Cambridge, Massachusetts, because you have Harvard, which is the biggest number of astronomers under one roof. Like during the pandemic, we had 700 people on our Zoom call.
Oh, dang.
Because it's the Harvard Smithsonian Center for Astrophysics.
Right. Yeah.
But all those beds, which is actually the majority of it, because they run the Chandra X-ray telescope, stuff like that. Wow. And if you get bored of those people, you have MIT, the other side of town, which is, a bunch of slouches. They've never done it. So, between the two, the amount of, astronomy PhDs, that's got to be the highest per capita town.
That would make sense.
Right.
That's amazing.
There's a lot so New York's not a bad place for sure. Because there's
I wouldn't say that. New York is great. The Flatiron Institute, for example, I think is one of the most fantastic, most interesting places to spend time these days doing astronomy. Columbia, once again, what a bunch of slouches. But I think just if we're talking like per capita, the way I could describe being at the CFA, the Center for Astrophysics at Harvard, it's like having a mini conference every week with all the number of people coming through.
That is amazing.
Cool.
And I do remember that the Event Horizon Telescope, right? Katie Bowman's the person who knit all of the software together to create
and they did that
amazing
at MIT.
Images. Right. She was finishing her thesis at MIT. And then she went over to Harvard to do her postdoc, and now she's at Caltech, of course, doing imaging sciences. It's just amazing. So that's really quite an axis, that Cambridge, Massachusetts axis of astrophysical superiority, I guess.
Also, shout out, across the river, then you have Boston University.
That's true. Yeah.
All these different places in New England. So.
Wow.
Yeah,
Okay,
Boston does have a nice concentration of colleges.
That's true. That's
and
true.
universities there.
Now, if we take New York, right,
Uh-huh.
Yeonmin's idea of New York and extend it like out of New York City, and we can bring it to Cornell, we could take it out to Stony Brook,
Yeah,
lots
Stony
and
Brook,
lots of places like
Princeton.
that. So
A lot of people, Princeton, New York.
that's right. New York, New Jersey kind of connection.
Right,
So,
yeah.
so that's not so bad either.
Yeah,
I'm not saying like it's bad. It's
Yeah,
just,
yeah, yeah.
Yeah,
And
yeah.
also,
If
like,
you had to
I
pick
spent
one
time
place,
in
that's
one
fair.
and not as
Yeah.
much in the other, so
Yeah,
I'm
that's
very
fair.
biased.
So-
Yeah,
pick-
did ask about the single best place, so that's
yeah,
a fair
except
way
if
to
I had
answer
to
the
pick,
question.
though, there was
Yeah,
like
but I
you
think-
could only talk, or you could never
one
leave
city,
the
right?
city.
One city. Yeah,
Right.
okay.
Yeah, I think that's fair. Maybe the single best place, but it's not a bad other kinds of places as well.
That's true. That's true. Okay, we all heard it here, everybody. Okay, Yvette recommends Cambridge, Massachusetts. All right, I guess I'll get my plane ticket and we'll head on out.
Yeah, all the
Sounds-
tickets, Ella.
The train. That's right, from New York, which travels at a respectable 120 miles per hour.
Yeah, it's a
I got it up to
beautiful train ride.
150 if you get the higher speed of the two
The
trains.
Acela.
Yeah, the Acela.
Wow.
Yeah.
And you
Wow.
get the nice coastal views on the one side of the train as well.
Yeah, true.
Oh, very cool. Let's talk a little bit more about what happens if you are looking at a black hole that's shredding a star. Because these shredders, they're too cool.
Yeah.
Okay. What does it do over the coming weeks, months, and years after it shreds? Like, you were looking at transients, right? Does it like, you said there's a couple of days, couple of weeks after that. But how do you look at it, say, over the course of months or years, decades? I mean, is there an effect? Does this happen a lot? Is it rare? I mean, what are these shredders doing? Because I'm
Okay.
excited about this.
So there's a couple things to unpack here. So the first is a shredder, or TDE, is actually very rare, even compared to supernovae. So these surveys that now look at, how many supernovae we found, like 18,000 every year now, or something like that. Last I checked, maybe 1 in 1,000 will be a shredder.
Wow.
So
they're
there's
very interesting. Our own Milky Way, maybe 1 every million years.
Holy
wow.
moly.
So because I know the supernovas in the Milky Way, it's once every like 100 years or so on average.
Yeah. So this is
That's
a
really
very
rare.
different
Wow.
beast.
Wow.
So that's the first one. I mean, 100, it could be 100,000, could be a million,
Yeah.
Small
It's
numbers.
astronomy a million.
Yeah. All within a factor of 10. Anyway, so that's the first one to say, like, these things themselves are very rare. However, as you can imagine, the unbinding of a star is a very luminous process.
Yeah.
So what you do if you're looking for one of these guys is you look and you first say, okay, this is basically at the center of the galaxy in which it occurred. So we know that statistically every galaxy has a supermassive black hole lurking at the center, for starters. Then you see this bright thing, you can optically classify it and then confirm that it's a TDE. I'm not an expert in the optical classification, but one of the things you look for example, is does the spectrum have a lot of hydrogen in it? Because the star has not exhausted all its fuel, so it would still have a lot of hydrogen in it.
That makes sense.
And then the light curve is also fairly characteristic, so you can make a classification that way. So, okay, once the TDE is classified, then people like me have our job where we have our radio telescope program ready to go, and we will swing our radio telescope there to see if we see any radio emission. So the radio emission is not from the actual unbinding of the star. The unbinding of the star and then the formation of an accretion disk and things like that is giving off the optical emission. Radio emission is from any outflows that happen from the central area where this shredded material is.
Oh, so it's further out. It's not
Yes.
actually at the black hole itself.
Yes, so
Okay.
we're looking further out. So I should backtrack for a second. So the process of how this happens, you have a tidal radius that is outside of your event horizon, right? So if it's a black hole greater than 10 to the 8th solar masses, you never see the TDE because the event horizon is further out than the tidal
Interesting.
radius.
Okay.
So 10 to the 8th is 100 million, which
Yes.
means that, say, in our Milky Way galaxy,
We
the black
could
hole's
see
only
it.
like 4 million. That's okay. But if we went to that first
M87
event,
star,
Yeah,
Oh,
the
right.
one with that nice picture from the Event
you're
Horizon
never going to see a
telescope.
TDE there.
I
Wow.
see.
So
I
we're
see.
already going for like also a specific kind.
So so these like
Mm.
not that big but not that small galaxies.
Yeah, so the smaller of the biggest
Okay.
black holes
Okay.
out there. And anyway, so when this happens, half the star gets flung outward, like on outward orbits, never to return. And the other half forms into an accretion disk around the supermassive black hole. Very little of the material when this happens actually goes past that event horizon to the
Interesting.
Okay.
That process takes a much, much longer time.
Okay.
But you are basically getting the huge luminosity because, you have an extreme environment around this black hole. The unbinding of the star itself is only a few hours.
Wow.
Jeez.
That is in itself very fast. As I said, it becomes quite luminous.
Yeah.
Optical people see it, they classify it. Then I come in looking at the outflows from these
So that
things.
part that got flung away.
Yeah. So what we're interested in is we will look, weeks and months, even years after the initial TDE happens, looking for radio emission from these things. And the reason we care about this is, a lot of people have worked out theory for how these things work from like gamma ray burst physics and supernova physics. We can apply those models to the radio emission we see, and then we can actually extract the physical parameters. So like the radius of the outflow, its energy, its magnetic field, even the density of material it's plowing into.
That's
These
awesome.
are all things we can get from the radio. So
that's amazing. So literally, even though we cannot see the stuff in there, we can see from its results, the spray, the destruction.
Mm-hmm.
Actual physical parameters.
Yeah, and this is important because, all these are millions and millions of light years away from us. So from that distance, they're all point sources. We can't actually see what the structure looks like when things are far away. But we can still figure out what they physically are like.
Wow.
Yeah, there's one point that I do want to add for people in the audience who may or may not know this. So tidal disruption events, the title there, this is the same gravitational effect that causes the tides on the Earth, like the water that comes up from the moon's gravity.
Yes, that's true.
But because it's around this black hole, which is so massive and so dense, it's enough to tear apart an entire star.
Yes. And the other way to put it is, so like our sun, to use our sun is like, if a comet goes too close to our sun, it will break apart into a bunch of different pieces. And that's because of the tidal forces as it gets too close to the sun. So this is the equivalent of the star going too close to that supermassive black hole. The same effect.
Makes sense. Yeah.
Amazing. Wow. I love that. That's super cool. Also sounds a little stressful, but that's okay in a good way. This is some serious destruction going on. So let me ask you, you must have something to calm you down, some non-astronomical thing that you do. Our guests all have fun hobbies and cool things to share with us. You must have something that you can share with us. Yes. What do you do? What do you do outside of this?
Well, different things. I like to read. I like to travel. And the big one, though, go home and I like to cross stitch.
That's fun.
Oh, okay. This is cool. Tell me the difference between knitting, crocheting, and cross stitching.
Can I show you?
Yes. By all means.
Great.
For those of you who are not on the YouTube version of this podcast, get on the YouTube so you can see what this is going on here. Yvette is holding up. Oh, wow. It is the JWST complex mirror.
So I will describe verbally for people who can't see. Cross stitches, you have the material and you're making little X's with the thread and you're repeating that over and over again. It's the original pixel art is the way to put it. So then you get basically a picture made of pixels.
That's awesome.
Fantastic.
That's true. This is one of my earlier ones that I made in grad school when I realized that
it's an 8-bit Mario thing,
the 8-bit
guys.
Mario cross stitch, which
That's
has
awesome.
the text, "What doesn't kill me makes me smaller," because great.
That is what happens to
This
Mario.
actually hangs out now where my PhD students sit. So
that is so sweet.
So it literally is just pixel art.
That's so cool.
But it's also very deep pixel art because, like you said, if this is the thing that helps you kind of decompress from thinking about violent events in the universe, this perfect cross stitch that describes it. Yes. What doesn't kill you just makes you smaller.
That's what happens to Mario when he gets hit by one of the Koopas. Or whatever.
And I've tried other things like embroidery and this and that.
You have even more.
Yes. Well, before we switch from cross-stitching, I'm going to show you guys, though, because I do a lot of astronomy cross-stitching. So this hangs in the office here for my...
Oh, how beautiful.
Somebody was asking earlier about cross-stitch planets. And stuff.
Yes.
Oh, yeah.
Those of you who are not on the YouTube, you got to get on, because this is an amazing piece of work. It is
that's
huge.
so nice.
It's
Oh,
like
I
a
will say this
portrait.
was a pattern. I did not design this myself.
Well, sure, but
The other
you
two,
got,
I-
you've
Is
got
that
all the
Eric Hoff
planets
down there?
Sorry?
Yeah,
Eric
looks
Hoff,
like you have.
the
So this
second
was
thing New
by,
Horizons visited.
It's called Climbing Goat Design. So shout out to her. It's Claire Bray. She actually has a physics
Hooray!
degree and now does like science cross stitch.
Oh, fantastic! Yes, I think right at the bottom is that thing that looks like two asteroids stuck together to one.
Yep.
And
Yeah,
that was the
So you
thing
look
that
at
the New
stars,
Horizons.
all constellations.
After it
obviously.
visited Pluto,
Yes.
it hit that.
And it's a log scale for the planets because obviously they couldn't be. on
Oh,
the
Oh,
scale.
that
oh
makes
my
sense.
gosh! It's even accurate mathematically, and it's beautiful.
Yeah, so that you can see
artistically.
all of them nicely.
Yeah. So
That's
yeah.
so cool.
Wow, that's
They
cool.
give
That
you this, you got to decorate it.
wow, did that take
100%.
forever to make?
It was actually part of it's called a stitch along. So like every year you get like every month part of the pattern.
Oh,
And then it's like, well, yeah, it does take some time, but then it's like a little bit every month and you can work
Makes
on
sense.
oh,
it.
I love
It
that.
still took me more than a year. I fell behind. It
That's
actually got me to
amazing.
finish it, I guess. Is the
That's
Yeah.
really cool.
Yeah, that gives you like that's a long time horizon too. So you
Mhm.
always know there's something there to go back to at any time. I
Yeah.
love that.
exactly.
Okay, so
And that-
that's cross stitch,
Yes.
and then you got something else.
yeah. So I don't
see
do
it.
this as much, but this
Oh,
is embroidery.
oh,
Oh,
embroidery.
nice.
And
Oh
this-
wow, folks, this is okay. You got to get on the YouTube, but if you're just on the audio, this is like a thing that looks like a big tambourine or large.
Yeah, it's
plate.
a hoop that's
Yeah,
about
it's a
12
hoop.
inches across.
Yeah, and it's
Big
this beautiful blue in the background, and then you
night
have
Guy
yeah.
embroidered. So
Yeah.
let me like zoom
Oh,
in
that's like
here. You can
the
kinda
entire
see.
northern hemisphere constellations.
Yep.
Yeah, that's those are the zodiac
Yeah, the zodiac, yeah, because the
constellations. You
ecliptic
got
is on
And
the
then we can
outside.
go in the
you got the
middle.
bears, you got
bear.
Draco.
Yeah, you got the summer
Cygnus the swan.
triangle hanging
Pegasus,
out
too?
there. Yeah, I can't
Yeah.
really
I
see
guess
from
it's
this.
with the great square.
Yeah, you've got everything. That's
Uh-huh.
amazing. And so this is done differently because
Yes.
embroidery
So
is
this is like embroidery's different kinds of stitches. Yes. There's also camelopardus.
Yeah, Camelopardalis. Yeah, love that
Um,
one.
So these
The
are different
giraffe.
stitches,
giraffe
not
constellation,
necessarily
yeah.
crosses. So like if I go really close in there,
uh-huh.
you kind of see there's a Scorpio, like you have like
Yeah.
circular stitches, or straight
Sagittarius there,
stitches.
too.
They all have different
Oh,
names,
yeah.
like
So
embroidery.
Wow.
they're not all little pixels. They're like different
Yes.
shapes.
So this
Like
one
a
I
vector
got
graphic instead of a pixel art.
like this is from Kiriki Press, I think is the person who made
Oh.
this. So you get basically the printed out lines and then
Uh-huh.
you're filling it in.
That's so cool.
Turned out real nice.
It's
It
beautiful.
looks really nice. Yeah, I love
The
that.
Harvard Astronomy Library back when they
Oh.
still they had
Oh,
an art show
fantastic.
for the summer for the astronomers, and this was
Oh.
the on the website like they had a printed catalog. This would be
That's amazing. Is there a
Nice.
whole art gallery at Harvard for like the art
well,
that
at the
astronomers
time
make?
it was like during the summer they had an exhibition, which was just like people who worked at CFA who did astronomy things could like
Wow.
submit something. But
That's
it's fun
real
because I
fun.
did get like a Harvard library,
Yeah, that's right. Exhibitry at the Harvard
Yes,
Library. Yeah.
exactly. So
That's so fun.
fantastic.
that on my CV. I just realized it's not on there.
Well, get it going. You're gonna put it on there with all your other cool stuff that you do.
Yeah, about
We
these
have so much.
shredders.
I know shredders. You could do a shredder. That which doesn't kill you makes you shredder. Ah, I like that. Okay, look. We have so much more to talk about, but we're kind of running low on time. How are you doing on time? Should we wrap
I'm
this up soon?
good. We still have time. I
Okay.
have to get home for dinner with the husband and kid, but
Ooh.
otherwise,
Oh,
yeah.
wonderful.
Nice.
That's so nice of them
told
to
him
be
I'd be
patient.
late, and he's in charge of dinner. So
Oh,
Awesome. Yeah, we appreciate
Thank you,
parent-child
thank
duos
you,
here
spouse
on
of
the
Yvette.
LIUniverse.
Yes, we really appreciate it. But
Uh-huh.
this is all great. No, and it's also great that professional scientists have kids
Mhm.
or other
I think
things
so.
like embroidery.
I'm a little biased.
Well, yes. Your complete existence relies on the fact that professional scientists have kids.
Yeah.
But never minding that, it's true. No, I think that's great because life, that's what we do, right? Astronomers, we're not just machines. All scientists, we're
Yeah.
people, and we do lots
I
of fun
always,
things.
like people will ask me like, what are good books lately for the public? I'm like, I'm sorry, but like when I go home, I do other things with
Yeah.
my time. Like I
That's
Right.
fair.
Yep. I like spending time with my family. I like putting little X's into fabric and moving pictures. Had to watch White Lotus and Severance this week.
Oh no!
That's like astronomers. They're just like us. Yeah.
Which one is more science fiction-y, the White Lotus or Severance?
100%.
Yeah, yeah. From what I know of it.
Okay,
I haven't watched either.
Very good
just
show.
Seeing the
Check it out.
previews.
Yeah.
Awesome.
Yeah, I'm a little leery of watching any show because once I get sucked in, I can never come out in the same way again. But maybe that's the whole point of TV shows and stuff, right? To try to transform yourself a little bit from.
I think it's also, for people like me who have small children at home, that need something to do once the kid's in bed.
I guess that's
something to have on TV while cross-stitching.
Nice.
Right.
We love it.
But at the same time, you are all over the internet. I mean, don't you have like a huge presence? And everyone, if you don't know, like part of the reason that I'm like flabbergasted that Yvette and I have not crossed paths professionally is the high profile stuff that she's done over the many years. She's had cover stories on Astronomy magazine and all kinds of other places. She's been everywhere. People know who you are, but why did I not know? I mean, is it because I'm missing some key part of social media, which, I don't know about? I mean, what's the deal here?
I mean, probably the key part is Reddit, if you're not hanging out on
Reddit.
Reddit.
So
I have heard of it.
Yeah.
But you haven't read it?
I mean,
Reddit.
It's a very popular website.
It is a pretty popular site.
It's more popular than, for example, Twitter ever was.
Wow.
Okay,
you guys educate me. Okay, what is this?
So the way I describe it.
What is this Reddit?
For people of a certain generation, do you remember PHP forums?
Yes.
Yes. Now they're all on one website. It's called Reddit.
Oh.
Yeah, the idea that you have text and comments and everything is like posts
so it's basically
and
you have subreddits, so like every single forum and every single thing from like cooking to astrophysics to funny gifs of cats.
I'm a fan of bread stapled to trees myself.
Yeah, like hit animals, for example, is a pretty fun one. Where it's just like
bread stapled to trees is fun. There's a bunch of people staple different like kinds of bread to different kinds of trees. Post pictures of it. They have like some rules about like don't staple to any trees that are going to get damaged by the staples.
Yes. Or anyway, anything under the sun and beyond that as well. There's a subreddit.
Wow. Okay.
Yeah, true.
Anyway. So there's a lot of science subreddits with millions and millions of people subscribed. Our space is the biggest one. Yeah, so if I look here, for example, our space has 27 million people, or 27 million intelligent life forms.
Yeah, they have the little fun
remarkable
flavor.
Yeah, that makes Twitter followers look all lame.
That's
amazing. Wow.
Yeah, well, what's cool about Reddit for me is that you subscribe to topics as opposed to individual people.
Oh, I see.
I mean, you can subscribe to
Jewish people, and maybe you should.
But those people subscribe to the topics.
Wow. So what's your Reddit, Yvette?
So my Reddit handle is Andromeda321 is my username. Which I've had on the internet since I was in high school, and I am too lazy to think of another name, apparently.
Wow.
Very fair.
That's a great name. No worries.
And it's one of the top users on Reddit if you count up the amount of points or karma, the upvotes that I've gotten.
Oh, that's nice.
Like on Reddit, period. And the reason it's famous is because I have a lot of comments that start with astronomer here. And I was very tempted to start this podcast here, but it would have been very redundant because you guys would have been like, we're all astronomers here. What's this?
I'm technically a math person, but yeah.
Yeah. Okay. We'll let you hang out.
Yeah, thanks. Appreciate it.
And anyway, so these astronomer here comments are basically just like if there's a new result. So, for example, we were talking about dark energy earlier last week when this came out. I saw that there was something and it was, you cracked the algorithm in grad school. It doesn't take me that much time. I'll stop. I'll write for 10 minutes, just like here's a quick summary of what's going on this topic in astronomy, and then post it. And then thousands of people will read it because, if something is millions of people are going to read it, then, a decent fraction of those eyeballs will then read the article or click and read the comments.
Right.
And basically this started because we all have our pet peeves. Mine is misinformation on the internet. And if I don't do this, then the comments are so terrible on Reddit. But so you gotta get
real.
in, you put the post there, and that's my public service to humanity / the
making people less wrong on the internet is a noble goal.
Yeah, exactly.
Thank you.
Because I have like a Google News alert, for example, for this user account. You'd be amazed at how many people will like write a news article and then say like an astronomer on Reddit, Andromeda321 says this. And I'm like, you should probably look into who I am.
Yeah, maybe.
But yeah, this is actually one of the funny things. So saying like people who are older than me in professional astronomy are like, what's Reddit?
Guilty as charged. Here we go.
And the students all know who I am.
Isn't that funny?
Yeah.
I love that.
And it's actually lovely because I get several messages like every month, even some months, from students who want to do astronomy and are like, I want to be an astronomer, what to do. So I wrote up a post, which is like everything that, I basically had thoughts on the topic. I'm not saying they're all the right thoughts, but they're my thoughts. And I send this up to students and I'll write or answer comments and this and that. Wow. And by now, these students are like in grad school and stuff in some cases. So one case is Kevin, who I had said earlier.
Yeah.
I first met him. It was a pandemic. So it was a virtual meeting and for recruitment for PhD at Harvard. And the student who was admitted from Puerto Rico wanted to talk to me. And I was like, I can do it, but I don't know who he is. And then we were all done. He's like, listen, I'm from a background in Puerto Rico where I didn't know anybody about in astronomy or how to do it or anything like that.
Wow.
But I found your post on Reddit and I did everything you told me to do. And now I'm trying to choose between Harvard and this other school and like this other amazing.
Wow.
And then we ended up working together and I'm like co-advising him. So
that's so cool.
Oh, that's so great. Thank you for doing that. That's really neat. You know, being able to tell people that what we do is accessible, not just accessible, but fun. And you should do it if you want to. I love that. And it sounds like Reddit is a great tool to do that. And I should get on this thing. But you know what? You're already there. So I can.
Well, let me know if you need any tips or advice. I'm happy to.
Yeah, we're going to have to talk a lot more about the Reddit stuff in the Patreon, okay? Because I have a lot to learn. Thank you. Okay. Well, we really have gone on far longer than we should have. We're out of time, but I would love to continue the conversation and do more. Yvette, come back again, okay? Will you please?
Okay, sure.
Thank you so much for being here. So one more time, give us that social media handle that we can reach you at, or any other way that we can keep up with the work that you're doing about shredders, TDEs, shredders.
Sure. So on Reddit, I am Andromeda321, or there's a dedicated subreddit. So if you do reddit.com/r/Andromeda321, that's the place to find me. The other place I hang out is Blue Sky these days. So where is Yvette.bsky.social is me on Blue Sky.
All right. Wonderful. Wonderful. Dr. Yvette Cendes, thank you so much for being on the LIUniverse with us. We really, really appreciate it. Thanks.
Sure thing.
All right. And as always, co-host Allen Liu, thank you so much for all that you do. Thank you, thank you, thank you, thank you.
You are welcome.
And for all of you out in the audience, thank you for being with us for this wonderful episode. I had such a good time. If you like what you see and hear, please support us on Patreon. And as always, thank you for being a part of the LIUniverse.